Section 1.3, we're going to talk about points, lines, and planes. We're going to define some vocabulary, talk about some notation, and we will use this throughout the whole year. So, a point has no dimension. So, you're probably like, what does a dimension even mean? So, what is a dimension? It's a measure of spatial extent, especially with height or length. So, if we go back, a point has no dimension. We name it with a capital letter. So, for example, here we have point A, and it always has to be a capital letter when we're talking about points. So, if we want to name it, we can say point A, or we'll just write the capital letter A. Okay. A line has one dimension. It has length. It extends without end in two directions, so it extends forever in both directions. It's represented by a line with two arrowheads. So we're always going to put two arrows to show that it extends on forever in both directions. And there are a few different ways that we can name a line. The first way is by using a script letter. So a line can be denoted by a lowercase script letter, like we see here. And we can write line L with the lowercase script letter. Or we can also denote a line according to the points that it passes through. So for example, we have line BC, and we can also call this line CB. It does not matter which order you put the points in. But notice the notation, it looks like a line right above our 2 points. Okay, and then we have line EFG, which has 3 points on the line, and we can use any 2 of those points to name the line. So for example, we can call this line EG, we can call it line EF, we could call it line GF, we could call it line GE, line FG, line GF. There's multiple different ways that we could name this line. We just need any 2 points on the line. So it takes at least 2 points to determine one line. A plane has 2 dimensions, length and width, and it's represented by a shape that looks like a floor or a wall. And there's 2 different ways that we can name a plane. Right? The first way that we can name a plane is by the capital letter. So you guys can see the M in the lower left-hand corner here. So we can name this plane M. You don't want to ever write just a capital M, otherwise that would denote a point. So we have to write the word plane M. The second way is by using 3 points on the plane. So we can also name this plane DEF. It doesn't matter what order you write the points in. You could also name it plane FED, or plane EDF, or plane FDE, as long as all 3 points are on the plane. So 3 points not on the same line are required to define a plane, for example, D, E, and F. If 3 points are on the same line, then they cannot define a plane. So name 3 points. We have 3 points here, D, E, and F. So to name a point, we use a capital letter. So D, comma E, comma F. Those are our 3 separate points. Name 2 lines. We have line P, that's our lowercase script letter, and we have to write the word line. And then we also have line M. Okay. Name 2 planes. We have plane Q. Again, make sure you write the word plane. Otherwise, if we just write a capital letter Q, it looks like we're talking about a point. And we have plane R. Okay. Collinear points are points that lie on the same line. Okay. Co means together, and then you can see the word line in linear, so together on the same line. So collinear points lie on the same line. Coplanar points are points that lie on the same plane. So for example, A, B, and C lie on the same plane, so we call them coplanar points. Then we also have coplanar lines, which are lines that lie on the same plane. So for example, I can draw in line M, and I can draw in line P, and they're both on plane F, so these would be considered coplanar lines. So name 3 points that are collinear. We have D, E, and F are all on the same line, so they are considered collinear points. So D, comma E, comma F. Name 4 points that are coplanar, so 4 points that are on the same plane. Well, D, E, and F are all on the same plane. And then the 4th point that's on that same plane is G. Okay, H is above the plane, so it is not on the same plane as those 4 points. Name 3 points that are not collinear, so not on the same line. D, E, and G are not on the same line. Yes, D and E are on the same line, but that's okay. D, E, and G are not collinear because those 3 together are not on the same line. There's multiple different answers you could give here. You could say H, E, and G are non-collinear, H, E, and F, D, E, and H, F, E, and H. So there's multiple different correct answers for this example. The last part that we're going to talk about is different parts of a line. So we have a line segment, which is a part of a line that is bounded by 2 endpoints. So instead of a line that extends on forever in both directions, we have a line segment. So here our 2 endpoints are X and Y, so this is segment XY. We don't have to write the word segment in front of it. This bar over the top is denoting that it's a segment. Notice it doesn't have the arrows on the end because it's not a line. So we use a bar to denote a segment. So for example, here we have segment BC with the bar over the top. We also could call this segment CB. It doesn't matter which order your letters are in. Same thing, this could also be called segment YX. And the last part of today's lesson is array. Array is a part of a line that consists of an endpoint and all points on one side of the endpoint. So here's our endpoint E and all points on one side of F. So it has an endpoint and it extends on forever in one direction. Now, the order of these letters does matter. Notice it looks like array. The notation for it looks like array. The endpoint has to be the first letter. Okay? So it has an endpoint of E and it extends on forever towards F. That would not be the same thing as saying ray FE. Okay? If it was ray FE, it would look like this. F extending on, oh, that is a messy F. We'll redo that. Ray F E. So this would be called ray F E. Here's a nice little summary chart. We have the line, the notation, it could be called line AB or BA. We have a segment with 2 endpoints, and then we have array with an endpoint extending on forever in one direction. Here's one last example. Draw 3 non-collinear points, so 3 points that are not in a line. So J, K, L. Then draw line JK. So line JK is going to extend on forever in both directions, so I need the arrows on both ends. Then we have segment KL, so that's 2 endpoints. And then we have ray LJ. So that is going to be an endpoint at L because it's the first letter here. And then it's going to extend on forever through J.